Okay, just another question here, exercise 2b, question 14. We're going to sketch the function y equals x over x squared minus 4. Okay, now to do that we should factorize it. So that is the same as x over, this is a difference of 2 squares, it's x squared minus 2 squared, so it would be x over x minus 2, x plus 2. Okay, remembering our steps, we've got first step, y-intercept, put x is 0, and you get that y is 0 over, this is 0 minus 2 is negative 2, and 0 plus 2 is 2, so we get 0 over negative 4, which is 0. So that's my y-intercept. So I'm putting x is 0, and I get y is 0, so it cuts here. When x is 0, so when y is 0, x is 0. Okay, that's what we've got so far. Now let's look at our vertical asymptotes. So vertical asymptotes, I look at my denominator, and my denominator cannot equal 0. So x plus 2 times x minus 2, or x minus 2 times x plus 2 can't equal 0. So we know that x cannot equal 2 or negative 2. So they're my vertical asymptotes at 2 and negative 2. I'm just going to put those in. Okay, again, we should be just looking at the behavior of the curve around negative 2 and positive 2. Just looking at a point slightly above and a point slightly below. Just be very careful when you do the negative one, because negative 2.1 is below negative 2 and negative 1.9 is above negative 2. So I'm just going to write what my function is here in factorized form. It helps if it's in factorized form when you're trying to do this. So I know I've got undefined at 2 and negative 2. Now let's look at 2.1. So that's positive. So that would be a positive over 2.1. This would be positive. 2.1, this would be positive. Well, it's positive. Okay? Let's look at 1.9. The 1.9 is positive over 1.9 minus 2, that would be negative, and 1.9 plus 2, that would be positive. So it's a positive divided by a negative is a negative. So at 1.9, which is just before 2, we've got negative value. And at 2.1, which is above 2, we've got a positive value. Okay, so that's my behavior near the asymptotes. We also know that when x is 0, y is 0. Now, if you want, you can substitute x is 1 into your equation. If I put 1 in there, I get, so I might just do that down here. When x is 1, let's just see what happens. Y is 1 over negative 1 times 3. It's negative a third. So that's all looking fine. I think it goes like this. So when x is 1, we've got negative a third. Okay. Now, let's keep going. When x is negative 2.1, I would have a negative over negative 2.1 minus 2. That's a negative, and that's a negative. So it's a negative divided by a, it would end up being a positive. It's a negative over a positive is a negative. So for negative 2.1, I've got a negative. And for negative 1.9, I would have a negative over, that would be negative, but this would be positive. So it's a negative over a negative is a positive. So a positive for 1.9. So it would be up there. Now, the other point you might want to look at is negative 1, but I would say it's down here. So let's have a look. When x is negative 1, what am I getting? I would get y is negative 1 over negative 1 minus 2 is negative 3 times 1. So it's positive a third, yes. So coming back up to the graph, when x is negative 1, y is positive a third. So it would go like this. Okay, now you just need to see what happens when x is 10, or as x approaches infinity and as x approaches negative infinity. Okay, now if you don't want to use when x is 10, just go something small, bigger. So when x is 50, I think 10 should be fine for this one. Whatever, 50 will do. And when, or even 100, whatever you like, and when x is negative 50. So when x is 50, you're going to get that y is 50 over 48 times 52, and you see what you get for that. And when x is negative 50, you get negative 50 over negative 52 times negative 48. Okay? When x is negative 50, I get negative 0.02. So when x is positive 50, I get, so this is what I've got. As x approaches positive infinity, y approaches 0 from above. So we can draw that on the graph. As x gets quite big, y approaches 0 from above. So it's, and as x approaches negative infinity, y approaches 0, but from below it's coming from the negative numbers. So over here, you would have an asymptote going this way. Okay? And make sure that that's getting close to the x-axis, which is, the x-axis, remember, is y is 0. So that's that curve there. Okay, look, there is a more formal way of finding horizontal asymptotes. So I'm going to just show you that quickly. Okay, now here is my equation. I'll do that on a separate page. Okay. So finding horizontal asymptotes. So for example, with this, y equals x over x squared minus 4. So to find a horizontal asymptote, what you do, there's a formula for it. So the horizontal asymptote is, so the horizontal asymptote is the limit as x approaches infinity. So remember, your asymptote as x approaches infinity, what I mean by that is as x gets really, really big, right, in the positive direction. So it's the limit as x approaches infinity of your function. Okay? Now, the thing is, you can't substitute infinity into here. So what we do is we divide each term. So this is our rule to find it. It's the limit as x approaches infinity of your function. All you do is divide each term by the highest power of x. Now your highest power of x is x squared. So we divide x by x squared. Then we divide x squared by x squared. And we divide that negative 4 by x squared. So what I'm doing here is dividing everything by x squared, because looking at this function, my highest power of x is x squared. So I divide the x over x squared. I do x squared divided by x squared and negative 4 over x squared. And then I simplify that. So the limit as x approaches infinity, x on x squared is 1 on x. X squared on x squared is 1, and 4 on x squared is just 4 on x squared. Now there is a rule. And the rule is that the limit as x approaches infinity of 1 on x is 0. Now, what this means is, as x gets really big, let's have a look. What's 1 divided by 10? 1 divided by 10 is 0.1. What's, let's say x was 100. What's 1 divided by 100? So an example is 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. See, as x gets really big, as x approaches infinity, what about when x is, say, 1,000? 1 divided by 1,000 is 0.001. We can see that as x gets really, really big, that the value of 1 on x approaches 0. Okay? So as x approaches infinity, gets really, really big, the value of 1 on x approaches 0. So that's the theory for this. So now the limit as x approaches infinity, I can now substitute. So the limit as x approaches infinity of this. Now I know that this will approach 0 because 1 on x approaches 0. When x approaches infinity, this 1 just stays the same, and 4 on x squared, so the limit as x approaches infinity of 1 on x is 0. Also, the limit as x approaches infinity of 1 on x squared, for example, is also 0, because that's 1 on x times 1 on x. So anything over an x or over an x squared, that will also approach 0. So what is 0 over 1 minus 0? That's 0 over 1, which is just 0. Now, if I look back, so this is the formal way of finding horizontal asymptotes. It's doing limit as x approaches infinity. Now, we didn't do that in our examples. We chose just to do substitution. So I've just done it for this. I just did now limit as x approaches infinity of this function, and I got 0. And as you can see, look here. So there's two ways to do it. You can do this, limit as x approaches infinity, right? The only thing this doesn't tell you is whether it's approaching from above or below. Well, that's the only thing, okay? But with this way, with the substituting, you can tell whether it's approaching from above or below. Because, for example, when x is 50, if I just substitute it into the same function as what I had, which was this, okay, I get 0.02. But the thing is, if you want to do negative infinity, you can't see that for this one, okay? We know they're approaching, we would know, for example, if it was approaching negative infinity, this would be a slightly negative value. So it'd be a negative, this would end up being positive because it's 1 minus something very small, and it would approach 0 but from below. But you can't tell where it's approaching from which side when you look at it like this, but you can if you're substituting. So, okay, just showing you another way of working out the horizontal asymptote. So I can say back here on my other question, my horizontal asymptote is y is 0, okay? And that's what I'm getting here. Horizontal asymptote is y equals. Because horizontal asymptotes are like this, and that is an equation of y equals something, okay? At this question 12, which was that really strange graph, you could also do the horizontal asymptote for that one using the method we just learnt. So if you want to do that as well, so for this equation, y equals x squared plus 5x plus 6 over x squared minus 4x plus 3. When we substituted for this equation to work out the horizontal asymptote, we got y is 1. As x approaches infinity, y approaches 1 from above. As x approaches negative infinity, y approaches 1 from below. So let's have a look with this new method. So the horizontal asymptote. Look, if you're comfortable substituting, then that's fine. Is y equals the limit, this is the formula, as x approaches infinity of your function. Now remember, we have to divide our function through by the highest power of x. So I'm going to divide through by x squared. So I will get x squared on x squared plus 5x on x squared plus 6 over x squared divided by x squared on x squared minus 4x on x squared plus 3 over x squared. Then I need to simplify it so that it's the limit as x approaches infinity of x squared on x squared is 1 plus this one. 1x cancels from the numerator and the denominator. I get 5 on x plus 6 on x squared over x squared on x squared is 1. 1x cancels from numerator and denominator here. I get minus 4 on x. And then I get plus 3 on x squared there. And then now I can just substitute. So I know that the result is the limit as x approaches infinity of 1 on x is 0. That's because as x gets really large, 1 on x would get very close to 0. So I now just replace my anything over x's or over x squareds with 0. So that becomes 1 plus 0 plus 0 over 1 minus 0 plus 0, because all of these will be 0. So that's 1 on 1, which is 1. So here you can see that you can work out the horizontal asymptote, and it ends up being y is 1. But when you do the substituting, you can tell that it is y is 1 and whether it's approaching from above or below. But remember, with that question 12, it wasn't as straightforward as the others. I had to have 3 or 4 attempts to get that. So, you know, sometimes it may not work out so well. Same with this one. I had to do several attempts to work out my my horizontal asymptote. Okay.